Welcome back, and here's part 2 of your population notes. In this set, we're going to answer 2 questions. 1, why is population increasing at different rates around the world? And 2, why might the world face an overpopulation problem? Before we do that, we're going to look at a model that demonstrates the pattern of population growth in countries throughout their history. Countries typically start in stage 1, and they start moving towards the right. Eventually, they get into stage 2. Then over time, they get into stage 3, and then they end in stage 4, and we'll talk about that progression as we work our way through the notes. On the left side of the chart, you see a scale from 0 to 50, representing how many out of every 1,000 would fit into where that line is located. So the blue line on the chart represents the death rate of a country. So in stage 1, you can see the death rate is ranging from anywhere as high as the high 40s and as low as the low 30s. The same can be said for the birth rate, kind of right around 40 or just a little less. And then as we move to the right through the chart, you can see that the birth rate and the death rate separate for a while, and then they eventually come back together in stage 4. The more distance there is between the death rate and the birth rate, if the birth rate's higher, assuming the birth rate's higher, the larger the rate of natural increase, or the more people you have. That's what this chart's showing. In stage 1 of the DTM, we're looking at human history, early in human history, 10,000 plus years ago, where there were high birth rates and high death rates, and they canceled each other out, so the population of the globe stayed relatively low. An event known as the Agricultural Revolution led to people settling down, having more children, and a higher birth rate. So you can see how it was like a roller coaster in stage 1. The red and the blue lines are up and down, but they are fairly close to each other, so the growth rate is just a tiny little set of hills just wavering up and down around the 0 mark for population growth. In stage 2, we have a high growth period. Around the 1750s, we start seeing countries around the world having a more rapid expansion of their population due to a large drop in the crude death rate. It had already been dropping after the Agricultural Revolution, but another historical event known as the Industrial Revolution, which led to higher productivity and wealth and technologies and healthier people that had the resources they need to survive. So we have even less people dying and living longer while more people are being born. That leads to rapid population growth. More developed countries, like countries in Western Europe and the United States, entered stage 2 around 1800. The remainder of the world then enters after World War II, and largely as a result of an event known as the Medical Revolution. So in stage 2, you can see the red line, the birth rate still stays high, but the death rate is declining. So the further those two get apart, the larger the natural increase rate, and the more population grows. And you can see in the chart here, as you get closer and closer to 2000 AD, note the population spiking up. Every dot is representing a significant stage of population. And then on the top of the chart, you can see the natural increase rate percentages and the doubling time, the amount of doubling time it's taken for population of the planet to double. The first doubling in our human population took almost 60,000 years. The most recent doubling took only 40 years. In stage 3 of the demographic transition model, we see moderate growth. And what happens here is the birth rate starts declining and starts getting closer to the death rate again. Main reasons for this is that you have more economic opportunities for women, education for women. Families are having less children because children are going to live longer. And as a result, you see smaller and smaller families. So in stage 3, you can see the red line for birth is declining at a pretty steep rate. The death rate is still going down, but at a much flatter rate. And so therefore the natural increase rate of the population is going down. And in stage 4, you have the birth rate and the death rate are getting close to each other again. The natural increase rate is getting near 0, or what we know as 0 population growth. And 0 population growth results from the total fertility rate of a country being 2.1, or right around that mark. That's the replacement rate of people. If 2 people are replaced with 2.1, that should equal steady population. The reason it's 2.1 is sometimes children do pass away before their parents, and so that 0.1 accounts for that. Countries like the United States and parts of Europe are currently in stage 4. So again, birth rate and death rate, you can see through stage 4, they're getting awfully close to each other, and because of that, the natural increase rate that is very low, it's below 10. And some geographers argue there's a 5th stage, the demographic transition model, and that's when the birth rate exceeds the death rate. And so when that happens, you're looking at negative growth. Countries who are in this stage are only there for a very short period of time because obviously if you think about it, unless they have lots of migration coming in or people immigrating into the country, they're going to have nobody left if you have negative growth for too long. So the 5th stage is just a temporary extension, in my opinion, of the 4th stage. Now, the other visual for us to be familiar with today is something known as a population pyramid. And so what you're looking at on the right shows us 2 things. One, shows us the number of dependents that a country has. So the number of people that are ages about 65 and up and 16 and down. Those are our dependents. Those are the citizens of a country that are relying on other workers to produce for them. That's what we mean by dependency. And then the other piece is we can figure out the gender ratio. So what's the number of males to females in each bracket? So the way that the graph works on the right, on the vertical axis from 0 to 90, those are age groups. So each bar represents a 5-year age group. So the bottom bar is representing the number of people in the country ages 0 to 5. And then along the horizontal axis, it's giving you the percentage of people in the country that fit that category. So the bars that are the widest are going to be the age groups where there are the most people. So when you look at this pyramid, it doesn't really look like a pyramid. It actually looks like there's a pyramid towards the top, and then it looks like there's an inverted pyramid almost at the bottom, and then it's fat in the middle. That means there's a large group of people that are getting towards the end of their working years, and it's an aging population. This is actually the population pyramid of the United States. This population pyramid is a classic pyramid that's going to show that a country that's going to burst with population growth. Cape Verde, which is off the west coast of Africa, has a graphic where it's very narrow at the top and it's the widest at the bottom, means it has a very young population, means they're going to be very likely to reproduce more and more people. Life expectancy in Cape Verde obviously isn't as high as you might find in other parts of the world. And so this type of country, if it has this classic pyramid shape, is considered to be part of stage 2, where the birth rate's still high, the death rate's on the decline, and population is growing. This is Chile's graphic, and Chile is a good example of a country that's in stage 3. So it's a emerging country, or soon to emerge. And so they have a pyramid until about age 30, and then down there it looks like it squares off between 35 or so on down. So that is a country that's in stage 3, is when it looks like a house. The birth rate is declining. The death rate is still declining, but just not as rapidly as the birth rate, and the natural increase rate is slowing down. Population is still rising, but it's not rising as rapidly as it had been at the beginning of stage 3 by the time it's at the end. And then Denmark, an example of a stage 4 country, is one where the birth rate and the death rate have gotten pretty close to each other, so the population has squared off, and you can see that the pyramid looks a lot like that of the United States. So pyramid up at the top from like age 60 to 90, then it's pretty square until you get down to about the 20s or so, 20-year-olds, and it inverts a little bit. So stage 4, then we're looking at pretty steady population growth, small families. Now, one geographer / economist who was very concerned about population growth back in the 18th century was Thomas Malthus. And his theory was simply put, highlighted for you, population is going to outgrow the supplies. He was really worried that if we have this unchecked population growth, eventually we're going to run out of food, we're going to run out of water and resources, and it's going to create a lot of misery for people around the earth. And so supporters of Malthus still see this as an issue because there are problems in the world where there are groups that don't have food readily available, and fresh water is tough for them to come by. And so some of those countries that don't have those natural resources need to rely on some others to help support themselves. But on the other side, there's critics of Malthus that have recognized that the supply that we have today is not necessarily the same supply that we're going to have tomorrow, because what we have are incredible technological increases that can help us improve our farming methods, can help us improve our ability to clean water. And so these technological advances are things that Malthus never could have considered when he came up with his theory. And so those folks would say it's a distribution issue, it's not a supply issue. Yes, some countries don't have it, but it's maybe because other countries have too much of it. And if they shared with each other, it probably wouldn't be as large an issue. One example on this chart is showing the country of India, its population as we are entering into the second quarter of the 21st century. You can see its population is over 1 billion. The projections are by 2050, India's population could be approaching 4 billion. And the worry is that its resources, which is the green line, is going to continue to separate from its population. There won't be enough resources for people there. And then you see by 2100, some projections, if they continue at the current rate, would have a large gap between those who are existing and the resources they need to exist. So that could lead to a lot of famine. The good news is, though, can be traced back to the 1960s, where there was a revolution known as the Green Revolution. Norman Borlaug, who is a professor from the University of Iowa and from Minnesota, introduced seeds and different types of crops to new parts of the world to allow them to grow rice and wheat that was more abundant. It produced bigger harvests and produced more food per square meter. And so as a result of that, the supplies went up faster than the population. So you could see through the late stages of the 20th century, India became much better off. They had way more supplies than the population needed. So supplies can be increased. When it comes to controlling population growth, most demographers would agree that a decrease in the crude birth rate is necessary. And the world's crude birth rate has been declining over the last 2 decades, which is good news. The two main ways in which the birth rate can be influenced is through economic and social development. So more economic opportunities for people, advances in education, more people choosing to pursue careers and put off having families till a little later in life, even by 5 years, can lead to a crude birth rate drop of 2 children per family. The other is contraception and that access to medical family planning. The parts of the world that have the least amount of family planning, and you can see that in sub-Saharan Africa, are going to be the same parts of the world where the birth rate is the highest. And I think that makes a lot of sense because contraception is designed to help prevent unwanted pregnancies. And if those things aren't available in a country, you're more likely to find unwanted pregnancies. So that is the introduction to the demographic transition model and population pyramids and an idea of what we need to do to control population. After this set of notes, there is a note check for you, and so I'm going to ask that you use these narrated notes. You can use the slideshow that I shared with you as well as resources to help you answer those questions. So it's open note. Make sure you refer back to these things as needed.